good afternoon. So far, I can see that there are people from Australia and people also from Dubai and from Spain. So we have a few people joining, some early racers like myself, although, it's not so bad, it's not so early here. Today, we're in this online session to talk about designing PV projects in Australia. And I suppose bifacial PV, which is what we're focusing on today, is a new innovation technology that is literally making huge leaps forward in terms of the projects that are starting to look into this technology. And it changes quite a lot the way that you have to think about your project on the engineering side, but it can achieve up to 20% efficiency gain. So it's important that you consider it when you're looking at your project, particularly because what we're seeing is as the competition of the competitiveness, if you like, of the technology goes up and up, you need to start to look at all of these innovations in order to remain competitive. With us today, we have two people who know and have been working with bifacial for a while, experts that we've already known before and we're going to hear from today. So I'd like to ask them to introduce themselves. Vaibhav, please, can you just say hi and a brief introduction of you and your company so that people know who you are? Make sure that you unmute.
So yeah, hello everyone. Thanks, Belen. Hello everyone. My name is Vaibhav Joshi, and I head the business development for Sterling and Wilson for Asia Pacific market. I'm based in Melbourne, and Sterling and Wilson, as you might know, is currently world's largest solar EPC, and we have been doing a fairly good amount of business all over the world. So I'm representing the Asia Pacific region for Sterling and Wilson. Yep, that's about me. Thank you.
And you guys are doing a lot of piloting and testing and twinkling with bifacial PV. I know that. I just wanted to confirm it.
Sure.
Correct. And you will be telling us about that. Okay, excellent. Javier, how about you? You have been looking into bifacial for a while, particularly because trackers here are a big deal, right? Can you tell us a little bit more about you and your company?
Yeah, sure. Thank you, Belen. So my name is Javier. I'm the regional general manager for Soltech in Australia. I'm based here in Sydney for about over a year and a half now. And yeah, exactly. Soltech has been involved in promoting bifacial technology for quite some time, doing testing in our Livermore test site in California. That I'm gonna start talking about in my presentation. So really excited to share all those findings and real life measurements with you guys.
Thank you very much, Javier. So this is what excites me. When we talk about a technology that is going to happen in X months, X years, we're starting to see a little bit of bifacial going down in some projects. I heard about this project, for example, in Egypt, but more and more, it will become more mainstream. So you need to find out now, because very soon, if you're not doing bifacial, you are out of it. So first, I'd like to ask Vaibhav, please, can you share your screen? And whilst he shares his screen and gets ready for his presentation, let me explain to you how this is going to work. First, Vaibhav is going to give a presentation, then it's going to be Javier, and then we will take questions. You can send your questions through the Q&A box. I see that you've already got some questions, so we will get to those when they are done, or to as many as possible as we can. And not to worry, we're recording this session. We will have the materials and we will send them to you, okay? So without further ado, Vaibhav, go ahead. Please make sure you unmute your microphone and let us know then about designing bifacial projects. Just need to make sure that you unmute your microphone. It's at the top. You have like a toolbar at the top. Or maybe Araceli, can you unmute it for him? There you go. Yes, can you put that in large? Actually, it was large before. Yeah, perfect. Off you go.
Yeah, so thanks everyone. So I'll just give you a quick brief about the bifacial, the good part about it, the bad part about it in my view. And then I think Javier will be the right guy to give you more data about the compatibility of bifacial along with modules and different terrains of Australia. So I think just to introduce what bifacial is, compared to a conventional monoperc or poly technology, bifacial is a technology that can use sunlight from both the side of the panel. There are various ways of doing it. Either, some module manufacturers are putting a glass glass kind of bifacial module, or otherwise sometimes you don't have a glass on the backside, but you have a transparent sheet. So both the options are available. Basically, the backside of the panel also absorbs the reflected light, and that gives you an extra generation. You can see bifacial modules coming in many forms. So you have a framed bifacial, a frameless bifacial. Then, as I said, there is a dual glass bifacial, and then you have a bifacial which has glass on the front side and a clear back sheet on the other side. One of the important things about bifacial is albedo. So albedo is basically, the reflectance which comes in from the ground, and based on the albedo of the ground, it is decided that what kind of generation you will get from the backside of the module. So I've just put in data from an REL source that based on different types of Earth surfaces, what kind of albedo or reflectivity you can get. So obviously, when we are talking about terrains which have, like the tropical ones, let's say Southeast Asia part of it, when you have the forest and big vast green grass and grass. So obviously the albedo is quite less. And as you move towards the transparent kind of surfaces, which can be sand, let's say example of Middle East, or let's say the snow or ice, then obviously your albedo increases, and then basis that your reflectivity increases, and then your gain from the backside of the module increases, and that's how the module generates more. So from the EPC perspective, I'll give you a broad outline on what are the cost parameters that we need to understand when we are designing on bifacial. So obviously, the first parameter is the module cost itself. The module cost for bifacial is high compared to any other technology, and we need to see whether this delta is good enough to compensate for the generation which is being offered. So that's one important aspect. In terms of the balance of system, your tracker cost increases to an extent, and it's mainly because you are putting bifacials at a height which is more than the conventional one. So obviously the length of your post increases, and then also you have to create a higher inter-row distance basis. Because of that, your cables increases, then combiner boxes, because you have added number of inputs both from the front and back, and also clamps. So there are a few BOS cost adders which come in, and installation, obviously, because the foundation lengths have increases, cable trenching has increases, so it increases your installation cost. There is a land cost which needs to be factored in, because obviously your row to row distance is going higher, and you have to decide a ground coverage ratio, which helps to compensate to manage the delta between the generation as well as the cost. O&M cost, this is another aspect which needs to be looked into. And in O&M, especially the backside cleaning of the modules, that's something which is to be factored in while we are creating the cost for the bifacial technology. Financing, I think now it is getting traction, and across the world now, the financial institution and bankers are understanding the gain which is coming out of bifacial. Though there is still a question that who guarantees or who approves that generation, because it's more of a it's more of a generation which is a data rather than a real ground one. But still, I would say for last 1.5 years, I have seen that it is maturing, and now the banks and financial institutions are good with financing. And then obviously, because of the larger land sizes that you have incurred, so your land and project development costs are a bit high. How do you get more yield? So what all is to be factored in when you are determining the yield? So obviously, as I captured, ground albedo is one important aspect. And so when we are talking about bifacial, we need to see in which kind of surfaces we are putting this project. So that's very important thing to see, whether the albedo is good enough or not. The soil type, the reflectivity of the soil, as I said. Bifaciality factor. So this bifaciality factor comes in from the module manufacturers. They give you the bifaciality factor of their modules. Then loss factors and degradation. In terms of system configuration, where the EPC role comes in more, is the kind of tracker height that you are putting in, the kind of pitch you need to determine for the bifacial, Another good aspect is the height and width ratio. You have to see that, how much high we can go compare in a bifacial, because obviously there is a delta beyond which height you will not gain as much as it was up to that height level. So that threshold needs to be checked. The DC-AC ratio, obviously, is very important to determine up to what extent we should go on the bifacial part. Tracker losses, which is obviously because the tracking, the different tracking technologies like 1P, 2P configurations, they have their different losses, and from the shading side, say from the back side, there is a shading effect which needs to be seen. So all these components, need to be understood when we are talking about the yield parameters which come out of the bifacial. So advantages, yes, there are advantages. You get a higher efficiency from bifacial, which is a known phenomena now. You have an extended durability because you are now into a glass composite panel, so they are highly protected against any environmental influences. You have more flexibility in the designing because now the direction of the module facing becomes less important, the bifacial, because of the bifaciality, because you are getting data from the reflected part, so maybe that can be compromised to an extent. You are getting an extended warranty. The degradation rate is low. There is no potential induced degradation because obviously now the backside is also glass based, and you can avoid the grounding. So because the frameless panels don't have any frame, so you can avoid grounding. So these are the advantages which you get in when you are using the bifacials. I would say the issues, so I've not kept it as only disadvantages. These are the issues which needs to be seen. So obviously a glass bifacial solar module becomes heavy compared to a conventional monoperk module. So obviously that impacts, the structure which is being used and the overall foundations. The selling of modules are only on the front data. The generation which shows from the front side. So you can't capture what will be the output of that panel, and you can't determine the pricing of the PV module. Albedo, which is the biggest factor here, it depends on the properties of the surface, and also within the plant you will see, it varies between at what space you are measuring the albedo and on which time of the day you are measuring it, what season you are measuring it. So imagine if you are measuring the albedo for 2 or 3 months, but those 2-3 months may be either the best ones or the worst ones. So you can't determine whether that albedo is good enough to, to set a precedent for the entire year. Between framed and frameless bifacial, there's another debate. So, frameless modules, they have less backside shading, but their BOS cost moves higher because you have to put in clamps there. Framed bifacial, good enough, but they have some disadvantages that they can trap sand or other soiling materials from the backside. Then talking about the irradiance mismatch. So there is a mismatch between the irradiance which is on the front side versus the back side, and similarly on the cell temperature. In terms of O&M, you have to maintain ground properties. So suppose, as I said, you measured albedo for, let's say you put an albedo meter on the ground, you measured it for 3 to 6 months, but now to maintain the same albedo, you might have to maintain the ground, and which, let's say if we are talking about a grass surface or something, it will take huge amount of maintenance. And another factor which we need to see is the backside cleaning, which is still not clear to 100%. So I think, yeah, that's pretty much from my side on the bifacials. So I tried to capture it from all the aspects, and I think Javier will be the right person to capture more in terms of his on-field experience with this. So that's it from my side. Thanks.
Thank you very much, Vaibhav. I'm going to ask you to stop sharing for now so that Javier can get ready his presentation as well. Javier, you've asked me a few times whether the presentations are going to be available. Yes, they are. Yes, we are also recording the session, so you don't have to worry. You'll have it. Keep sending the questions so that we can get to them thereafter. And are you ready, Javier? Just make sure you mute your microphone.
Yeah, all good, ready.
And bring that into the large screen for us, please. So at the moment we can see the large screen, but also the little one. Perfect. Off you go then.
Okay. Yeah. Thank you, Bifa, for your presentation, and thank you, Belen, for facilitating the webinar. So I just Bifa has touched into the main parameters that we need to consider for bifacial, And then from our side, Soltech side, and the structural side, I would like to get more into details on how we get these numbers, where do they come from, and hopefully the outcome of this presentation is to be able to walk out with specific numbers, specific ideas that we can implement into our modeling today, and see see how changing these parameters impacts on our sites that we are currently developing. So a little bit of our introduction about Soltech first. So Soltech is one of the top tier single-axis solar trackers manufacturer, more specifically the double module in portrait tracker, out of which we've got currently 6.4 gigawatts of track record all around the 5 continents, and we've got an experience altogether of about 15 years and 6 gigawatt of production capacity. Out of this track record, I should emphasize as well that over 1 gigawatt is currently being contracted to mount bifacial modules in different continents. So really interesting times indeed. All the content from this presentation has been extracted from our Bifacial Tracker Evaluation Center in Livermore, California. This is a site that was developed by Soltech and inaugurated in June 2018, just with the objective in mind on understanding what's the difference between mounting monofacial modules with bifacial modules on a structure and on our site, and really get into the deep numbers on what parameters we should emphasize and focus on to maximize our yield. All the variables like the albedo, the GCR, the heights of the modules, the shadow interference losses, but also some very interesting developments like the tracking algorithm optimized for bifacial. So first of all, I'd like to touch on very rapidly on what we're talking about bifacial gain. We're really, it's a very simple equation that compares the gain on our structure with a monofacial module with the equivalent with a bifacial module, and this comes out of the modules in what's called the bifacial gain. And the bifacial gain really has 2 main factors: the module bifaciality, which Bifaf has already touched on that, and it's really dependent on the technology on the module that we're using. So this is a conversation we should have with our module manufacturer of preference. And then we have the bifacial ratio, which is nothing more than the ratio of energy generated from the from the rear side compared to the front side. And this is where we really, as a tracker manufacturer, focus on in order to maximize the yield that we are squeezing out of our modules and of our site, and ultimately translating lower in our LCOE. So where does the first question is usually, where does this radiation come from on the rear side? So it comes out basically two main sources, out of diffuse radiation and out of reflective radiation. So putting all of them together, as we can see on the top right, the bifaciality is that something that comes out of the PV module, and then for maximizing that diffuse and reflected radiation, we need to look into the albedo, the pitch, and the height, and the rear shadowing, which are the parameters that I'll be touching on later in this presentation. And these are parameters that are given by the soil of our site of choice, our layout, and our site constraints, and then the racking and structure, either fixed or single axis tracker that we are using. So we can run quick numbers here on this table at the bottom. With, for instance, with a 19% albedo, we can assume a 10% bifacial ratio. That altogether with a module bifaciality of say 75 or 80%, that will give us a 7.5 or 8% bifacial gain. This is general rule of thumbs. So now really starting into these different parameters that influence our gain. I would like to point out first that these numbers are real measurement field values that we're taking out of our test site, and it's that we've released already in our 3 months worth of data in a form of white paper, and that you guys can go check out. So first of all, focusing on the albedo, which is a parameter that is given by the soil of our site of choice, we've allowed in our test site for 3 different scenarios. So we've allowed for an untreated ground conditions that were left seasonal, and then we've allowed for 2 constant albedos along the year. One is gravel, another one is white. And we can see that this is one of the highest, if this is the highest parameter that affects our bifacial generation, and it's actually impacts on a linear fashion. At the moment on that seasonal soil and albedo, we've got dirt in which there is grass now growing. So hopefully we will see how the evolution of the yield changes with the evolution of the ground conditions. Now getting into more structure specific, we've seen here that there's an inconsistencies with the modeling softwares that we've been currently using and we've traditionally using for monofacial simulation and modeling, yield modeling, and when we use them equally with the bifacial system, we've seen that the numbers don't really are not really similar to the ones that we are measuring on site. So I'm going to give you guys the specific numbers for being able to make as similar as possible your modelings from our real field values. And the first one, when talking about the structure, the most important is the structure shading factor. So here traditionally, the modeling softwares have considered for a rectangular in unlimited plane with no interferences. So when we're assuming the same conditions on the rear side, the numbers don't really add up. So there's a need here for a more specific modeling of your tracking structure and being able to input this in PVSys or your modeling software of choice. By running this more comprehensive and complex modeling, we can see that there's a difference with a 2P tracker and a 1P tracker. And being the 1P tracker, we've been able to get a value of 0.7 shading factor compared with a 4.5 shading factor of the equivalent modules, but on a 1P tracker. Where does this difference comes from? Well, it mostly comes from leaving intentional gaps along the tracker. So we've left intentional gaps along the slew drive and along the torque tube. But not only that, so we also have lower amount of components underneath the modules that improve the interferences of the rear generation due to the radiance coming from the backside, and that altogether we need to look into other things that we haven't traditionally looked into on our monofacial simulations, our monofacial sites, like the cable management, avoiding the hanging wires, avoiding cable trays that may cause an interference on the rear side. So we can really easily now, same as in the as in the front side, on the rear side, we can really easily understand and see where are those points of concentration of energy in the module through an image, infrared image, which is really telling us where are the areas in the module that are receiving the less radiance and that may cause a problem in the long run on the 25 or 30 years life of the module, like high degradation of specific areas. So this is definitely a parameter that we need to look into. Then on the structural point of view, we also have the height of the module as another key parameter, and it's a key parameter from four different aspects. So first is that a higher module allows for an increase of diffuse radiation underneath. So this is we can clearly see that because an object that is closer from the ground casts a darker shadow, whereas an object that is high from the ground, the shadow that casts is more grayish, so that allows for more radiance coming underneath. Then another parameter, another reason why the module height is so important, it's the module radiation reflected underneath. This is basically coming out of trigonometry 101. So when we're assuming similar angle of incidence on the rear side of the module, we can see that the module that is higher from the ground views more surface area on the ground. And this is what's known as the view factor. So high view factor means more radiation underneath, which translates directly into more yield. Then we have another reason, and that's the distribution of the radiation underneath the module. So by running quick modeling, thanks to modeling done by a German university, we can see that a module that is elevated 1 meter from the ground compared with a module that is elevated 2 meters from the ground, as we can see on the bottom left image, have very different distributions of the energy on the radiance on the backside of the module, as we can see on the bottom right picture. And this really makes an impact of our generation through what's known as the mismatch. So mismatch is a very serious parameter to take into consideration, both on the front side and on the rear side. And what we've seen and we've measured on our test side is that we should allow for a 2P portrait like an SF7 bifacial mismatch loss factor of 6% compared to a standard 10%. Then another parameter that influences our generation, it's the GCR of our site. We are all familiar with this value. It really makes a difference when designing monofacial sites with increasing or decreasing your GCR, because you can squeeze out more energy out of your modules with the same components. But really on bifacial module, we can see an even higher difference, an even higher delta of this generation. So for instance, we've taken in Bitec a base case of 10 meters as a reference, which for a 2P tracker, it's equivalent to a 40% GCR. And then when increasing that to 12 meters, we can see that there's a 2.4% increase in production. And then on the bottom side, if we reduce that just by simply 1.3 meters, we get an 8.5 reduction of our production. So it's very significant here. And bottom line is that the more we can spread out our system, the more we'll be able to extract from our components. And then the last factor that I would like to touch on in this presentation, is the module temperature. Is the operation temperature of the module. So when we're talking about bifacial and bifacial gain, this really translates into the real life. It's that our module is it's taking out more current than the equivalent compared to monofacial. So that higher amount of current that's flowing out of our modules, it's directly translated into higher operational temperature. And what we've seen in Bitec, when we're comparing different modules installed at different heights, it's that the higher modules on a 2P tracker compared with the equivalent to 1P tracker reach out to the faster and cooler higher streams of air, and therefore allows for a better temperature of operation, which can go all the way up to 6 degrees Celsius of operation. This is a very significant finding. But on an average day, we can assume a 3.5 degrees difference between similar modules installed on a 1P tracker compared with a 2P tracker. Again, this is very significant because a lower operation a lower temperature of operation allows for a better efficiency of the modules, and therefore this is translated directly into a better generation. So with what we've concluded, what we're seeing is that those 3.5 degrees Celsius difference on operating temperature is equivalent to a 1.3% delta in energy yield generation. And this is the main factor that we've seen in our biotech. And the way we can input this into our modeling at the moment, it's by what's called the thermal factor in our PVC simulations, that we should set up with our system as 37.7 watt per square meter Kelvin, compared with what would be standard of 29. We've seen this delta of operation temperature that has a certain trend with the ambient temperature, but not only that, also with the air that flows in between the corridors of the trackers, and this is something that we are currently studying more in depth to understand better. And just to summarize all the points that I've been speaking in the past slides. So when we're considering a double row of module in portrait single axis tracker mounted bifacial system, we can assume that on a high reflective area and a high reflective surface, we're going to get a 19.2% bifacial gain. And when we look to the equivalent similar conditions, similar GCR and similar albedo conditions equivalent on a 1P tracker, we can see that there is a 2.4% difference in our generation. And again, this is measured field data that have been validated by a third party. So it's these are very interesting findings indeed. And when we are reverse engineering this 2.4% difference, what we're seeing is that half of that 2.4% comes out of having a lower average module temperature, so a better cooling and a lower temperature of operation of our modules. Then we have that 1/3 of that difference comes from the minimizing the interferences and minimizing the shadowing on the back side of the modules. And then there's another 0.4% that is accounted with other different design improvements and design details, like higher modules and the different pitch and the higher pitch. So as I was saying at the beginning, well, our objective with this presentation is to be able to walk out today with real numbers on the table that we can use today in our solar farms that we are currently developing. And by putting together all these numbers and these measurements on our test site, we've come up with what would be the critical parameters to really fine-tuning our modeling software to match the outcome of the modeling to get it as close as possible to our real life field measurements. And these critical parameters would be, as I've mentioned before, the shading loss factor, the thermal factor, and the mismatch loss factor. So hopefully this has been of use for listeners, and yeah, thank you very much to everybody.
Thank you very much, Javier. I think it has been really useful. I have 1 million questions, more or less, give or take. You guys have Javier's email on that presentation. You've got Vibhab's on his presentation, so feel free to reach out. If you have any further questions, I think it's become quite clear that the experts are here in this room at the moment. Okay, we have some questions, and we're gonna launch into them. So there has been a few questions. Some of them you've answered, but I want to bring them into attention about the cleaning. How do I clean the back? And it's not clear to anyone how that is clean, how even we'll get to the bankability side. You know, even people say, hey, how do you prove bankability for this? So I'd like to open it up, guys. What are the cleaning opportunities for the back of the panel, and how often does it need to happen? And you know, how does that go? Vaibhav, do you want to start to give, you know, like a 2-minute break to Javier, and then we can take from there?
Sure. So one thing which we need to understand is that you know, the soiling on the back side of the panel is not the same as on the front side of the panel. In fact, on the back side of the panel, the soiling will be much less compared to the front side of it. So having said that, I mean, let's say if we are considering 1.5 to 2% soiling for the front side of the panel, the back side will be quite less soiling loss. So you might not have to clean them as many times as you had to clean it from the front side. That's one. When it comes to frameless module, I mean, obviously, when it's a frameless module, it's the same type of cleaning which you are doing on a front side, nothing different from that. When it comes to framed modules, one of the challenges is that, you know, when you are cleaning it from the back side, maybe there are some particles which can get trapped on the back side of the module. So that's one challenge. But overall, cleaning, obviously there is much more to, you know, research and work on that. But the backside cleaning is not that much prominent required as on the front side, because obviously the, you know, the soiling and you know, the deposits will be much less compared to the front side of it. So maybe that's a way to think about it.
There is also a question here about from Manuel. I'd like to say hi to Manuel Poces, an old friend. You know, we've known each other for years. So hi, Manuel. Thank you for sending so many questions. It says here, could you share the number of cleanings per year on the back part of the panel, specifically in Australia? Is it different in Australia? I suppose that's what we're getting at.
Yeah. So as I mentioned, Manuel, I mean, the soiling losses on the front side versus the back side, there is a good amount of difference. I would say to an extent, you know, you can consider the losses on the back side are, let's say, 1/4 to an extent of the front side, let's say. So your cleaning cycle, when you are cleaning, maybe, you know, you don't require the same amount of backside cleaning as you require on the front side. So in Australia, typically overall, I would say, you know, the cleaning cycles are 1 or maximum 2 for the, you know, modules. I mean, we don't go beyond that anywhere, because I mean, the deposits and, you know, the soiling is not that high as compared to, let's say, if you're talking about something in Middle East or, you know, those kind of the markets. And
why does it have to be dry cleaning?
Ideally, yes. Ideally, dry cleaning is the right way. So for cleaning the modules, that's what I would say.
But why? What's the reason?
Again, the same. Again, you know, the deposits. I mean, in terms of when you are looking about the deposits, they might be more prominent when you do the wet cleaning. And overall, in terms of efficiency, also we are finding dry cleaning is a much better mechanism. Maybe Javier can add to it from his observations also.
Javier, I was going next to you, so would you like to add anything? If not, I've got questions for you. Just make sure you unmute your microphone.
Yeah, so from our point of view, that's definitely a question that we are working on. I agree with Bifacial that the rear side of the module doesn't need to be cleaned as frequently. There's no soiling and there is no there's no water that comes from the top. But yeah, it's definitely something that needs to be worked on more in detail with the structure manufacturers.
Dear Javier, how do you get 63% albedo? Special treatment or layer applied to the ground? Do you have some examples?
Yeah, so that 63% albedo was on the area of our site that was specially treated with a white coating. So it simulates what would be snow in some way. So it's a highly reflective surface that, yes, indeed has been coated for purposes of the tests.
Okay, there is a question here that I don't know whether either of you can respond. I mean, I'm going to think Vaibhav probably more. It's asking about breakage rates, whether it's the same or higher in frameless bifacial modules. Any of you has any idea or indication? I'm sure from the EPC perspective, you consider those things, Vaibhav.
Yes, I mean, there can be an issue about the breakage, but overall, I mean, it's more about the handling, and you have ways to handle the module. So I don't see there might be more breakages when it comes to a frameless modules. It's all about handling. I mean, it has nothing to do with the bifacial part of it. I mean, yes, we have glass on both the sides, so the handling has to be taken care. It's similar to when we are using a CDT technology from First Solar. I mean, the same handling issues, same kind of handling issues have to be captured here. But I haven't seen any significant breakages because of bifacial.
Okay, let's see. I had one.
I just agree with that. There's no difference with the monofacial or bifacial in regards to framed or frameless. There's a difference with framed and frameless, but there's no difference with bifacial or monofacial.
Okay, let's see. So here says how I don't know whether you've answered this actually, Javier, but just what do you do in PVCs when you simulate energy generation in terms of albedo? What do you use for that?
So there should be a text box in one of the parameters to input in PVCs is the albedo. So what you need to do is to go on site and understand what's the albedo on your site and measure that. There's ways of measuring that, and that should be one of the first things that you need to do on site for being able to run these simulations. And then you take that number and you input in your PVCs modeling.
Wow, I have so many questions, and they keep coming. I don't know where to pay attention to. All right, let's see. Oh God, this is very specific. Would you recommend the use of geotextile to cover the soil and to improve the production?
There's been many ideas around for being able to improve the reflectivity of the ground. And again, the albedo is one of the key parameters, so you want to maximize it. But then it comes into, you need to take into consideration that surface that you are putting in, you're going to need to maintain it and probably sometimes replace it several times along the 25, 30 years of your solar farm. So this really just comes out of cost. If the cost of doing this task exceeds what your extra yield that you're getting out of it, then it doesn't make sense.
Do you want to add anything, Vaibhav? I'm going to keep on sending you questions because we have so many, see if we can give
I agree with Javier. So as I was saying in my presentation also, as Javier said, you can put an albedo meter, test it for 3 to 4 months, but after that, you have to maintain the same albedo, and that means you have to maintain the surface. So I've heard examples of people using, putting kind of marble flooring on the surface, So just, it's all about you have to reflect it more. You have to reflect it more. So if there is a grass, you have to remove the grass at regular intervals. You have to have a grass cleaning cycle. And, in terms of, as I said, let's say Middle East, where you have desert, you have shining desert, maybe there you can get more generation out of it. But overall, it's about maintaining a surface, and it has a cost for sure.
And here, one of the people asked, what devices did you use to measure albedo? Do you want to recommend anything particularly?
Well, it's called an albedometer, I think. And it's like a pyranometer, but puts upside down, basically. So measures what amount of light gets reflected from underneath from the ground rather than what amount of radiation comes out of the sun.
Okay. Do you want to add anything, Vaibhav?
Yeah, so I was just mentioning, I mean, as Javier mentioned, there are 2 pyranometers. One is facing up, one is facing down, which is there. But one of the tricks is that, when you are putting it for testing, at what height you are putting it, that's important. And then finally, when you are designing your engineering, what height you are keeping for the panel. And are they 2 on the same lines, or are they different? Because maybe you might have put albedo at a lesser or a higher height compared to when you finally put the modules. So maybe that needs to be seen very well.
Okay, question for you, Javier, here. It says, I have heard from a European colleague that Soltec is trying to utilize an idea to redesign the tracker structure and enhance albedo, not bifacial gain only. Can you share any detail on that?
Well, if that's true, I'm not aware of. any specific that we're trying to implement, what we try to do is with the knowledge that we've gained over all of our tests and partnership with our customers, is to provide a service in which we show to our clients what will happen when you change specific parameters like the albedo. And again, similar with the geotextiles, it's just putting down the numbers. We can help optimizing the modeling, and then if you think that the cost of improving those measurements for improving the albedo are worth for the outcome that you're having on your simulation, then it's something that you should consider. But it's more of a service that we provide to our customer, more of something that we ourselves Soltech provide.
So in other words, get in touch with them and let's speak privately about the specific needs you have. Okay, there's another one here that says, what about the performance of the combination half cells bifacial and 1P trackers? That should be better than 1P trackers plus full cell modules. Honestly, I don't even understand the question, but I hope you guys do.
Yeah, so basically the question is more around the module, with whether it's full cell or half cell. So obviously half cell module with a 1P or 2P configuration will give you more output. What do you say, Javier? I mean, leave it to you.
Yeah, no, definitely. There's been a lot of talks in the module manufacturing space. There looks that there's a trend now for the half cut cells, and that definitely plays a key role with the numbers that we've got. So the half cut cells, they generally run at a lower operating temperature. So the numbers that have been sharing may be impacted on what type of module technology you're using. So definitely, again, a lot of things in this space comes out of cost. The half cut cells now at the moment, they have a higher cost than the full cell. So you need to take that into consideration as well. But yeah, definitely the outcome gets influenced.
All right, guys, it's impossible that we're going to answer them all because they're just coming in. As you answer one, two come in. So I'm going to ask you, I think, a couple of last questions. One was the one that I cannot find in this list, but I know it was there. So I think Vaibhav might have answered by text, which is, what's the difference in EPC costs, really, percentage-wise, from a normal, straightforward PV project to a bifacial project? So that was my question. So if you actually can start with that. And the next one is about bankability of bifacial particularly, but let's start with that one. Vaibhav.
So in percentage, it will be typically variable because the EPC cost in Argentina, Chile versus Middle East versus Philippines versus Australia are quite different. So obviously, in terms of percentage, it can't be a benchmark.
What about Australia then, since we're talking about Australia today? I'm not letting you get away with this.
so in Australian context, let's say if we add the delta of module, a little bit delta on the BOS, I would say 4.5%, 5% is the extra for the entire EPC with bifacial compared to monopuck, between 4 to 5%.
More or more than?
More, obviously, higher.
Okay, it's higher. Yep. All right.
4 to 5% in Middle East might look to be 7-8% because of the kinds of EPC cost you have there. So that's why it can't be a benchmark on percentage worldwide.
Okay.
Yep.
So it's good to know. Now I want to talk about bankability, guys. This is a very important, I suppose, milestone. There's a lot of questions here. Some of them are technical, but I think there was a lot also about bankability. So I'm interested to see, what are going to be the challenges that we're going to find? How do you prove, I suppose, the yield of the backside of the panel? Because my guess is, someone's pointed out, this is what's going to be what the banks are going to be like. I don't understand this. Any ideas? How would you go about this? What do you think are going to be the issues? How can they be overcome?
So I responded to one of the questions also. The biggest question here is, who guarantees the backside generation? Does the module guy guarantees it? Does the tracker guy guarantees it? Does the EPC guarantee it, or does the developer guarantee it? So that's a tricky question. And basis that, as I said, 1 year back when we were talking about bifacial, this was more of a data, it was more of a database analysis rather than a real analysis. But now what's happening is in last 1 year, I would say we have started getting field data. There have been projects that had been installed. I remember a project being installed in Mexico, another one in Middle East, which will be under execution, and Australia, obviously there are a few projects going in. So now the data is there, and based the data, the banks are getting comfortable. But yes, the why question remains is, all said and done, you have a gain coming out in the module, you have a gain coming out in the PV assist, but finally who guarantees it? And that debate always remains between the developer and the EPC. So
in the end, it's you guys, isn't it? Isn't it you?
So it's an open wide question, I would say.
All right.
But yes, I mean, overall as a technology, it is getting further accepted, and you have now field data coming in. So that's what I can say.
What about you, Javier? What do you have to add to this particular discussion?
I don't really have much to add to what Vive had said. It's really the measurements and the real projects what will make this technology bankable, and proving now with more tests and more modeling that those softwares that we normally use can really get very accurate on what on the outcome, and really present to the banks a number that they will feel comfortable on signing on. So it's maturity of the technology, and it's more projects out on the ground.
So as technology innovation is actually speeding up over time, and particularly deployment is speeding up over time, when do you expect that most of the projects, and by most I mean more than 50% of the projects, will be bifacial? By when? When do you think, okay, from here on? This is my last question, by the way, so that when we can say goodbye, we've been here nearly an hour, but I just want to say, when is this going to become mainstream? Who wants to start?
So everything that is coming now through the desk, I mean, everyone, every opportunity wants to test bifacial for sure. So that's the trend. I mean, in any project that is getting into the stage of discussion, or let's say execution, bifacial is one of the versions which has to be worked upon by default now. So that is the extent of, adaptability of bifacial, and that is the extent everyone wants to understand the gain out of it. But again, at the end of it, what technologies finally decided to implement the project will depend on the LCOE. So, but yes, I mean, as a concept, bifacial is getting traction. Every bid, every project that is happening does have a variant of bifacial also during the initial stages. But yeah, towards the finalization of the project, I mean, finalization of the EPC and the contracts, does it stay in the same race or not? It depends on the LCOE and LCOE which comes through, but overall there is an acceptability and requirement of bifacial for sure.
But you haven't actually answered my question. What year or when? 2021, 2022, I don't know.
That's tricky. That's tricky to answer. As I said, Belen, up to an extent, everyone wants bifacial, but whether it actually gets implemented at the end of it, it's quite subjective. So you can't have a trend there.
Okay. Javier, would you want to add anything, or just also to say goodbye, some last comments? By the way, thank you very much for your very detailed presentation. I'm sure people will pore over all of the details.
Yeah, so I just wanted to point out that I would say 2018 and 2017 were the years of test sites. Everybody was asking for test sites. Everybody wanted to look at what's this new technology, what was it about, and what real impact was in real life. Now this year we're seeing the large utility scale solar farms worldwide. I'm talking globally here. From the first early adopters, those that implemented those test sites in the first place, they were seeing the outcome, and they've got now large-scale solar farm projects. In Australia, there's not that much of traction now, but I think it's just a matter of economy of scale here and getting familiar with the technology. The modules at the moment, you're paying a premium for having them bifacial compared to monofacial. I would expect, as the module manufacturers ramp up their production, economies of scale will kick in at some point. So hopefully in 2020, 2021, that difference will not be as high, and then it will be a no-brainer when you've got a site, and therefore similar pricing, you'll be able to get a bifacial model compared with a monofacial. It'll be pretty easy choice.
Well, excellent. Let's declare 2020, 2021 the year of bifacial, and hopefully we'll start seeing more and more of these projects. We're already seeing them, and we're talking about them all the time, but it'll be interesting, you know, when more start popping up everywhere. Thank you very much for your time, guys. Thank you very much, Vaibhav. Thank you very much, Javier, for being here with us today. And thank you very much to all our participants for joining us from very many different places in the world. We'll see you next time. Okay, we're looking forward. As you know, we do a lot of these this webinar on different topics. So we're looking forward to receiving you again in the next time round. Thank you very much. Bye.
Thanks, Belen. Thanks, everyone, for joining in. Thank you. Bye-bye.